Good morning, superhumans! Before I get into anything else, I acknowledge the traditional owners of this land. I pay my respects to their elders past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, live stream. Hopefully this is working. Looks like we're alive. Interesting question already from Daniel Watson. Okay, so there are a whole lot of the regulars here today. Good morning to Johnny, Frank, Dodgy, Henrik. Who else have we got here? Mitchell. Andy. G'day, Andy. Austin's Creations as well. Yes, I am live. We have not yet broken the internet. Now, okay, so I was not really feeling like live streaming today. Just on a slight personal note before we get into other things, it's been a bit of a rough week. My daughter's cat had to be put down a couple of days ago, very unexpectedly. She seemed to be fine, and then her stomach became a bit bloated up. Took her to the vet, and they did an ultrasound and discovered that she had a very large cancer, and so we had to have her put down. And this cat has been my daughter's best friend since she was about 9 years old, so she's been understandably super upset. So it hasn't been a very fun week, and I saw on Discord there was, I can't remember who it was, someone said that they'd had to have their dog put down a week or so ago as well. So yes, I know we're not the only one that goes through this sort of thing, but it's not fun when it happens. Very, very sad. So I got up this morning and did not have a whole lot of motivation to do a live stream, but this is exactly when we need our friends, isn't it? So I get to hang out and talk to you, which is really cool. So thank you for coming along to the live stream. What else? Okay, so, well, you can probably see, yeah, thanks Joey and Jose. Frank, yeah, so it was Frank who was talking about that on Discord. A couple of things. You can probably see right there is a toaster sitting on the bench, and beside that, just there's a box that's got a 2-year controlled RGB LED strip in it. And the reason I've got a toaster sitting on my bench is that I've been doing more of the 2-year video, and I've just been using that as a prop. I brought it out this morning, grabbed it out of the kitchen, and I did a little bit of filming this morning actually before the live stream. So I really want to get that video out. But I'll get there. Alright, the other thing, if I move my head, and you can see everything's, which way? That way, okay. The Superhouse sign, James Kennewell's amazing sign, is up there. And the other thing I was doing this morning was just trying to diagnose that flickering problem. And I keep going backwards and forwards between it being a software problem and a hardware problem. It only does that when I turn the brightness right down. And I'm just going to switch to RGB toaster mod. Yes. Where can I find? I think I minimized that window. I was just going to look for here it is, the WLED interface window. So I'm going to bring this over and switch to my desktop view so you can see what I'm looking at. So you can see over my shoulder, if I move my head that way, you can see the sign, and you can see the WLED control panel here. And you can see I've got the brightness turned right down. Now if I turn the brightness up and let it do its update, you can see that there's no more flickering. It's just smooth. Well, if I bring it right up here, it'll be fine. See, it's all nice. But the thing is that the brightness there is so high that the camera can't actually make it out properly. It just ends up like a big blur. So what I want to do is bring the brightness right down so that the camera can actually make out the individual letters. And you can see that what happens is that on the right hand side it starts doing that crazy flickering. Now I've pulled the back off it and looked at the power supply setup, and that all seems fine. I've measured the supply rails and it's getting a nice clean 5 volts. There's no brownout issues, and also the thing is that this happens when the brightness is turned down, not when it's turned up. So I removed the voltage regulator modules from the back, all except one, and isolated that section and made sure that it's getting the current it needs. The voltage is perfect, so I don't think it's a power supply issue. And if you look in the interface here, you can see that there are these segments set up in WLED. So we've got segment, I'll spin them all down, and you can see that there is a segment from 0 to 161, which is segment 0. That's a special case segment in WLED. And then segment 1 is 214 to 234. We've got 161 to 214 and 234 to 385. Now there are some weirdnesses about this because the segments are not meant to overlap. So you can see that segment 1 ends at LED 234 and segment 3 starts at LED 234, and so that really should be LED 235, but when I change things in here, for some reason the setting in WLED keeps reverting back to what it was before. I've done things like resetting all the segments, and somehow they magically just come back to this setting with overlapping numbers, and according to the WLED docs, you're not meant to have the numbers overlapping. So my next step is, I think, to do a clean upload. I'm just going to take the current release binary of WLED, reflash it onto the D1 Mini that is running this, and start with a totally clean software installation, and then define the maybe have no segments to start with. Now the reason that this is set up with segments is that the sign is actually in 3 parts, and you know, I'm chasing squirrels, but this is a fun squirrel and it's shiny, so let's chase it for a moment. Now the way that sign is actually made is that it's 3 PCBs, and let's have a look at them and marvel at how many LEDs there are in here and how tight they are. So what have we got? Eagle, Archive. So I grabbed, the design for this is actually up on James's GitHub account. So where is it? S for Superhouse. What have I got? Super. I can't read very well. What is going on? Maybe where is it? Superhouse logo PCBs. There it is. Okay, so it's divided into 3 sections. So we've got Super Word Board. Let's open that one up. And check this out. Look at all these LEDs. Now there are a couple of layers here I might turn off just to make it a little bit, get rid of the restrict layers and keep out layers. What else is there that's bitmap? Yeah, okay. There are some BMP layers in there. So we'll turn those off just so we can see what's going on. So you can see that this PCB says the word super, and it is just a very long string of LEDs. And in fact, funny thing is, if we go to the schematic, look at this. It's just LEDs, one into another, all the way along, keeps going and going and going and going. So yeah, you can see that the data is, let's have a look at the way this is laid out. It's a classic RGB LED string. So we've got a ground connection, like common ground to everything. We've got a common supply to everything, and then data out from each segment comes along, goes into data in on the next one, and then data out from this one goes to data in on the next one, and that is how WS2812 LEDs are connected. It's basically the data lines are all in series. Data out from one goes to data into the next. So, and when you have a lot of LEDs, you get a bit of a crazy schematic. So that is, in fact, hang on, let's look over here. So we've got, this is on the design manager, LED 1, it's rolling down, 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 down. Oh, hang on, let's sort by name. Scrolling down, 160. So there are 160 LEDs in the word super, just there, which is a lot of LEDs. And this would have been fun to put together by hand. I don't envy James having done that. So back to here. Anyway, we've got this super PCB. So what you can see is we've got right here, signal in. This is where data comes in from the WS28, no, not from that, from the from the D1 Mini. So this is LED 1 right here, and then we've got the ground connection, because the whole top of the PCB is a ground plane, and the whole bottom of the PCB is a 5-volt plane. So what you can see is the 5-volt connection to that LED is going through a via or a via. I need to start saying via because every time I say via, people laugh at me. But I learned that word from books, so that's why I pronounce it via. So power comes from the far side of the board. So each of these LEDs has its connection to the ground plane. It's got its connection from the other side of the board for power. Data comes in here, signal in, and then data out from this LED goes to data in on the next LED. And then out from that one to in on the next, and out from that one to in on the next, and so on, all the way around the board. And so it starts there, and it loops there, and then comes up there, and back around, and all over the place. So it's a whole lot of LEDs to put on the board. And if we come back to here, so the next board in the series is the logo board. Yes, I want to load it. And similar thing. So you can see here the power connections, and because one side of the PCB is ground and the other side is 5 volts, it doesn't actually need tracks to go anywhere. There is a pad here which is ground, and that just connects to one of the copper pores, and there's another pad there which is 5 volts which connects to the other. So it looks like they're not connected to anything, but in fact they are. And if I run a rat's nest, we can see that the ground is connected to the top side of the PCB, and the 5 volts is connected to the bottom side of the PCB. So I'll rip that back up again. And so we have that central PCB, which has the logo in it. Same deal as before. So because this PCB is the middle of the three, it has the data in coming in from this side. So this is the input coming in, and then once it goes all the way around the loop, so you can see the loop starts here, goes around the entire thing, and then the last LED in the chain I think is this one, and that out, so that's the data out, which comes all the way across the board, and it comes up to this pad right here, which is the data out to chain into the next of the PCBs. So if you apply power to this and you put data into here, you got yourself an RGB LED string and data coming back out here, so they can be daisy chained together. So you could get a few of these PCBs if you wanted to and just daisy chain them all and treat it as a single long string of LEDs. Excuse me. House word board. It's the same thing, but let's just look at this last one. So we've got data coming in to the word house. Now this is the board where the weird stuff is going on. And if we go back to here so you can see it, you can see super and the logo are working perfectly, and it's the house board where all the flickering is happening. And So you can see, for example, oh, well, you can see there's data coming in here, same deal, and it ends. Is there a data, is that a data out? Is that D out? I think it is. Okay, cool. So D out is broken out here, even though it doesn't go anywhere because this is the last word. The output from that LED comes out and it's broken out, so there'd just be no connection to that. I hadn't even noticed that before. But you could chain this together with another one. They're all just long LED strips. Same deal, we've got 5 volts and ground connected to the PCB. Hey, wrong screen. Just staring at me, you should be staring at this. Okay, this is what I was just trying to show you. So this is the end of the word house, and you can see the data output coming from here going to a pad. So you could connect more RGB LEDs to that if you wanted to, and just make it part of the string. So you can see the power here, top and bottom of the PCB as before, and you can see a couple of other things. So there's a power connection here, which just goes to the same thing. So electrically, that 5 volt connection, and that 5 volt connection, and this 5 volt connection, and in fact that one, and that one, they're all the same. They all just go to the back of the PCB where the 5 volt plane is. So you could connect to any of them. And in fact, the way that sign is set up, there are multiple voltage regulators, and it's feeding into different connection points. And that's just to make sure that there is enough capacity in the voltage regulators. So, excuse me, hang on a second. Does mute work? Mute? That's better. Clearing the throat. Alright, so, what am I looking at? Lost my train of thought. I'm not really with it today. Alright, so, lots of LEDs. And what I've noticed is that the flickering seems to occur, well, the position where it occurs moves. And if you look at this board, the end of the LED chain is on the right, the start of the LED chain is on the left. And the lower I turn the brightness, the more the flickering progresses across from the right towards the left. If I turn the brightness up a little bit, the flickering starts further and further along. It gets closer and closer to the end of the chain. And if I turn the brightness down, the flickering moves across from the right hand edge and is comes almost all the way across to the start of the H. Very weird behavior. I don't understand it. And the thing is that it works perfectly if I have the brightness turned up. So if I come up here, I'll just turn the brightness up, move my head out of the way, and as you can see, the flickering's gone away. It's perfect. It's nice and smooth, exactly the way it should be. But if I click on here, turn the brightness down a bit, see, it's flickering just towards the end of the word house. And if I turn it down a bit more, the flickering progresses further across the word. And the lower I turn it down, the worse the flickering is. Odd. I don't get it. Anyway. Andy suggested putting an oscilloscope on the data lines on the third block of LEDs to check signal quality and test sending the same set of data bits continuously. Yeah, so one thing that I thought of doing is isolating each of these segments. Because the PCBs, it's 3 PCBs butted up against each other end to end, and then there's just a little jumper wire. So the output of the chain from the logo comes into the input of the chain to the word house. So it's trivial from the back of the sign to simply remove that jumper and then feed data directly into it. So one thing that I was thinking of doing is basically doing that. I'll just separate the 3 segments. I'll take the data from the D1 Mini and send it straight into the word house and just run the house segment totally isolated from anything else. Oh, I just thought of something else that would be really interesting to try. This would help nail down whether it is a hardware problem or a software problem, and that is to change the order of the panels. The reason is that we've got 385 LEDs. Now, if it is a software problem, if I take the data from the D1 Mini and send it into the word house, and then take the output of house and send it into super, and then from super into the logo, now if the problem changes so that it's the logo that starts doing the flickering, then I think it's probably a software problem. But if the flickering occurs still in the same position, it's probably an electrical problem. Anyway. But yes, Andy, you're right. I could stick an oscilloscope on it and see the signal. So Matt just said add scope test points on the PCB. Yeah, at the moment there aren't any test points, but there are points where I could test, if that makes sense. So looking at this PCB, for example, most of the links, the data in, data out links, are just on the top of the PCB, and they pass under the LEDs, like under the body of the LEDs or wherever, like, you know, it just goes from one to the next. And I can't get to the front of the PCB. It's all glued together. So the only thing I can do is look at the back of the PCB. But there are a few places, like here, for example, you can see that the data connection coming out of one LED, so D out here, has to duck under a track. So it goes down a via, goes along the back of the PCB, and comes back up a via. And what that means is that anywhere that happens, I can access that on the back of the PCB, and then I can use that as a test point. So these little vias just here are exposed on the back. The solder mask doesn't cover them, and even if it did, I could always just scrape solder mask off. So anywhere that these little data lines jump around the back of the PCB, like here, there are a few of them, I can get probes onto the back of that. So I can access all of these points and do testing. So I could do things like inject data directly at that point if I wanted to. If I really wanted to do some testing, what I could do, for example, is come part way along the chain, like down here, and I could cut this track on the back of the PCB with a scalpel and then inject data just into this LED and from there into the rest of the chain. And then later I could just solder a little strand of wire or solder bridge or something across there and reconnect that. So each of those points becomes somewhere that I could segment, I could break the segment and then deal with just a subsection of the string of LEDs. So Stephen W. said the whole front side is flood-filled ground. Yes, that's correct. That might have been responding to someone else. I have not been paying enough attention. So DefPom said it's probably still flickering, but due to the timings of PWM and data transfer, it will cause longer off times. Yes. And Mako said, doesn't a long chain of LEDs need voltage injected part way too? It can do, but that's actually taken care of on this. The reason for doing that, if you've got a very long chain of LEDs, the current for the further LEDs on the chain have to pass along the chain. And if you've got just regular LED strip, the conductors are fairly small, so you end up you get voltage drops. So what you do is you run a parallel conductor down the strip, and then you supply power down the strip further along, so that you can avoid those voltage drops. Because what you can do is easily run much heavier wire than the thin trace that is on the LED strip. But in this particular case, the entire PCB is a ground plane and also a 5-volt rail. So there should be no problems at all with voltage drop. The only possible problem would be if the power supply could not keep up with the current requirement of the LEDs, and so you're getting voltage trooping. But I've tested that. That's not happening. The voltage is staying rock solid on 5 volts, and I've tested at multiple points across the PCB. It's 5 volts. And the thing is that you can test that really easily pretty much anywhere, because if we zoom in and look on here, for example, the 5 volts to this LED goes through this via that goes to the far side of the PCB, because the far side of the PCB is the 5-volt plane. And in fact, now that it's highlighted, you can see it everywhere. So we've got little vias all over the place linking through to the far side of the PCB, and every one of those I can easily access from the back of the PCB. So I've put a multimeter on it and I've checked the voltage on many, not all of them obviously, but many of these points, and it's rock solid. It's just 5 volts, spot on the money. So anyway, it's an interesting little thing to try to solve. Okay, so Frederick said, does the D1 Mini have a level shifter to cope with the 5 volts of the WS2812 LEDs? That is a great point and a very good catch. In this case, I don't think it does. Now, this raises an interesting issue, which is driving WS2812s or 13s or any of these addressable RGB LEDs from a 3.3 volt device. And it's one of those things that is technically out of spec, but usually it works. And the thing is that as long as the first LED works, then you're fine, because as Mike said, the signal levels shouldn't be an issue because each LED acts as a repeater. And it's possible to, in fact, let's, this, I can't remember where, but somewhere just recently this came up as a question. Where was it? I think it was on Twitter. Someone was talking about level shifting and LEDs, and I included something about this. Where was it? It was in a talk I did a couple of years ago. Was it the Donkey Car Electronics talk? Might have been this one. And so this was at the Open Hardware MiniConf a couple of years ago. Come on, Keynote, you can do it. And yes, this is where it was. Cool. All right, let's do a little impromptu presentation, just for the fun of it. Okay, awesome. So this is one trick that you can use to make sure that you're driving a 5-volt LED correctly from a 3.3 volt microcontroller like a D1 Mini. And so this is the standard setup. And unfortunately I can't highlight nets on this because this is a screenshot in a presentation. It's not actually Eagle. But you can see in this case, GPIO 18, we've got a data line coming in here, data into the first LED, and then we've got power here, and we've got ground down here, and then we've got data out, comes up, and then data into the next LED, and so on and so forth. And there is a diode next to, not a diode, a capacitor next to each one to provide a bit of power decoupling. Now, that is actually an interesting point. There are no capacitors, as far as I could see, on the on that sign. And according to the the specs for the WS2812B, you're meant to have a capacitor on the supply line right next to every LED. I don't know that that would be related to this issue, but it's possible. Maybe that's got something to do with it. It doesn't explain why it happens just on that one part of the sign though. Okay, so anyway, back to what I was talking about. So we've got data coming in here, and the LEDs here are running at 5 volts. Now, this is the issue. So we've got 5 volts being supplied right here, and that means that in order, so the way logic levels are defined, it's generally as a percentage of of the supply line. So in this particular case, for for excuse me, for the data input to the LED to register as a logical high, so 1 or whatever, it has to be at least 0.7 times the supply voltage. Now, because the supply voltage is 5 volts, we need to drive this line up to 0.7 times 5, which is 3.5 volts, for this to see a logical 1. But if we are running this off a D1 Mini or some other, any 3.3 volt microcontroller, it's going to be driving a data level between 0 or close to 0 and close to 3.3 volts. But 3.3 volts is not high enough to register, according to the spec, a logical 1 on this, or a logical high, whatever the encoding scheme is. I don't even know what it is on WS2812s. It's so long since I've looked at that, I can't remember. So, yeah, it might be like a grey encoding scheme or something. I don't know. It's probably just 0, low is 0 and high is 1. But I can't remember. And so we've got data in, losing my train of thought here. Data in needs to be driven up to 3.5 volts according to the spec. Now, the thing is that is what the spec sheet says, and the LED is guaranteed to work if you drive it to 3.5 volts or higher on the data line. That's like the minimum threshold. They guarantee every single LED is going to work at 3.5 volts or higher. But the thing is that there can be some variation in manufacturing, and the actual level at which it receives a 1 is probably lower than that, and probably significantly lower than that. So most of the time you can connect a 3.3 volt microcontroller to a WS2812B, and if you're driving 3.3 volts or close to 3.3 volts on the data line, the LED will probably still work. And now the interesting thing is that the way these LEDs chain together, you can see data out from here going to data in on the next one. Because the LED actually has a little integrated circuit inside it, and it is running at 5 volts. It's got this 5 volt supply line. So what it will do is drive the output line at the proper specified voltage. So the data out coming from this one will be at 5 volts. So if you took this input, for example, and you drove it up to 3.6 volts, so it's just over the threshold that it's guaranteed to work. What happens is you've got 3.6 volts coming up on the data in. You don't get 3.6 volts coming up on the output. You get 5 volts because the driver chip inside here is directly driving the data. It's got, basically you can think of it as being like a built-in buffer. So as long as the first LED in your chain sees valid data, the rest of them are fine, because each one of them buffers the data and drives its output to the correct levels. So the question is, we've got this problem. So we need to drive this input to 0.7 times VCC. So here's the trick right here. What you can do is put a diode in the supply line of just the first LED. So like a 1N4148 or whatever. It doesn't need to be much, because the amount of current that is pulled by just the first LED is fairly minimal. It's going to be, I'm making up numbers off the top of my head here, but LEDs typically will do up to about 20 milliamps. So if you've got 3 of them, so we've got red, green and blue, and we're driving them hard, if you had them all turned on maximum, you're talking about something in the region of 60 milliamps, give or take. It's around 60 milliamps running down into here. So you don't need a big power diode or anything. As long as it can handle 60 milliamps, it's okay. So what happens then, though, is that the diode provides a voltage drop. So we're supplying 5 volts in, and then the LED, a diode typically, like a standard silicon diode, has a 0.6 volt voltage drop. And so what happens is that you get 4.4 volts on the output of the diode, and that is the supply voltage going to the first LED. Okay, so that means that the first LED is running at 4.4 volts instead of 5 volts. Now, running at 4.4 volts is just within spec for a WS2812. So that's okay, it's going to run at 4.4 volts. But what that means is that now our requirements are different on the data line. So the data that comes into the LED still has to be 0.7 times the supply voltage, but now it's 4.4 volts, which means we only need to drive it to 3.08 volts in order to be within spec and to definitively have a logic high coming into that first LED. So what happens then is the first LED is running at 4.4 volts, and the input data is within spec, running off a 3.3 volt microcontroller, and the output, this is what I was getting at before, I was jumping the gun, the data outline here is being driven at 4.4 volts because the chip in here is running at 4.4 volts. So what we're getting is 4.4 volts coming out of the data outline, going into the next LED, which is running at 5 volts, and 4.4 volts is higher than 3.5, so it's not ambiguous, and everything is happy. So last thing, this is the little bit of magic. So if you take a string of RGB LEDs and you separate the power line for the first LED only, not for the whole lot, only for the first LED, you've got to isolate just that 5 volt input to it, run it through a diode, then you're golden. Everything works. The slight downside is that the first LED will be very slightly not as bright as the rest. So if you've got, if you're doing this just with 2 LEDs, so exactly as it is in this little schematic here, we've got 2 LEDs, and if you had those 2 LEDs sort of near each other and you were driving them both the same, you would notice that the first one is not quite as bright as the second one. But in something like a whole string of LEDs, like you can see, you know, there, and as we were saying, excuse me, and as we were saying here, if, for example, that first LED was not quite as bright as the rest, you'd never notice, because it's surrounded by all these other LEDs, and it would be just fine. Alright, I need to take a quick look at the chat. What have I been missing? Oh, Mako said, are they WS28XX? Yes, they are 2812Bs, I believe. Oh, Dodgy said, if they aren't on the same PCB, would they have the same ground plane? In this case, oh, that is a really interesting question. My immediate reaction to that was just going to be, yes, of course they are the same. But no, there is an interesting subtlety here, because there are different voltage regulator modules. Now, the voltage regulator modules, I think, have a common ground through from the input to the output. If they didn't, you're right, they would not have the same ground plane, which would mean the data voltage may not be relative to the same thing, because 0 volts is not really 0 volt. Everything is relative. Now, quickly thinking through this without explaining myself, I don't think that's a problem. But Dodgy, you actually raised a really interesting question there. All right, so let's dig into this just a little deeper. Alright, so we've got 5 volt and ground here, and the data voltage coming in up here is relative to ground. Now, if all of these PCBs had ground connections jumped from one to the next, then yes, you are right, they would all have a common ground that is tied. So a 0 volt reference, alright, I should, people get upset about using the term ground versus 0 volts or whatever. So I'm going to say, instead of saying ground, I'm going to say 0 volts, just for the purposes of being pedantic. But it's because ground, technically we are not at ground potential here. What we're talking about is a 0 volt reference, and then 5 volts is relative to that 0 volts. Now that 0 volts could actually be at some higher voltage relative to ground, or it could be at lower voltage, as in true ground. So imagine we had 0 volts and 5 volts on these two connections, and then we had two PCBs side by side, and they were being fed by different power supplies. They both have a 0 volt and a 5 volt connection, but their 0 volts may not be the same. They could be offset by some amount. And that means that if you just bridge the data line through between those two PCBs, that data line may not be at the same voltage reference to the 0 volts. This is the sort of thing that is much easier to explain with diagrams than with words and waving my hands around. I hope you're following what I'm saying. So, if these different PCBs were being supplied totally independently by different power supplies, and they did not have their ground connections or 0 volt connections bridged across from one PCB to the next, that could cause big problems. But we are safe here, and in fact what I would do, my preference here, now that this has been brought up, I probably wouldn't have thought of this if you hadn't asked the question, Dodgy, so it was a good one. What I would probably do is provide 5 volt and ground at both ends of the PCB and bridge them across so that the ground is definitely common in each of those spots. Oh, my throat's not doing well today. Okay, so that would guarantee that we would have a 0 volt reference across that's common across all the PCBs. However, we are lucky in this case because we get in fact, let's have a look. We get a common in negative, yes, we do get lucky. In fact, I'm going to bring up some alternative camera views and show you what I mean. I hadn't prepared for this, so I'll start up the microscope camera and the overhead camera, and I'll make sure their HDMI captures are turned on, and then let's have a look at this. So let's have a look at where are we? Overhead camera? Yes, overhead. Alright, so let's see how far we can zoom in on this. Because I've been playing around with the power supplies on this, let's see how far we can go before it. Yeah, it won't focus beyond there. About there. Come on, focus. Focus. Alright. So, right here, these are the voltage regulator modules from the back of it. And I ended up disconnecting modules and rearranging the power rails just to see if it was a power problem, which is why I've got these ones out loose. But what you can see here is that we've got in negative, in positive, and out negative and out positive. So in here we have 12 volts coming in on the input side, and we get 5 volts coming out on the output side. Now the key here is the connection between the in negative and the out negative. If those are bridged across on the PCB, it means that we are going to have a common ground, because the ground will be bridged between all of the voltage regulator modules. So let's start up the trusty multimeter in continuity mode, which, so you can hear we've got continuity there. Now, one thing that can be a trap, if you're checking continuity on power supplies, sometimes it seems like there's continuity when there's not, because there will be capacitors and things. So you can actually trick your multimeter into thinking there's continuity. I've left it on for a little while and it's stayed. Often what will happen is that you'll touch it and you'll get a beep, and the beep is just because you're charging a capacitor using the test voltage, and once the capacitor has charged up, then the beeping stops and it seems like you don't have continuity anymore. And then the capacitor might leak, or it'll discharge through a resistor or something on the board. You take your probes off and then you put them back on and it beeps, and it can be really confusing. So anyway, this is actually true continuity. There is a direct connection on the PCB. In fact, let's have a look under ye oldie old-time microscope, and let's see what we can find. Zoom it out, get some focus. Get some focus. There'll be focus there somewhere. Ah, here we go. Nice, we got focus. And a bit of visual inspection, and you can see that it actually is connected. You can see this large part of the PCB, it's very glary. Turn that brightness down. It doesn't need as much for the camera as it does for my eyes. So this major part of the PCB in the middle here, that's a copper plane, and you can see that the negative side of the in is tied to it and the outside is tied to it. So yeah, you can see, it's a little bit hard to see there. There isn't even any thermal relief. You can see that this pad is simply an exposed part of that plane. It's directly connected. This whole plane is connected to the negative side of the output, and the entire plane is also connected to the negative sign of the input. There is no gap there. There is no thermal relief or anything. It's just a straight through connection. And that means that we don't have a problem with our ground reference. So that was an interesting little squirrel to chase. Thanks for bringing that one up, Dodgy. It's definitely worth thinking about. It's really important to make sure that we need a whiteboard cam. Aaron just said yes. What I should do is get another camera. Do I have one? The problem would be capturing it. I've got another one of these cameras that I use for the overhead cameras, and I could mount that on the wall over there pointing at my whiteboard, and then I could just look yeah, you just walk over there and start drawing diagrams. I could just draw diagrams here. Like if I go to the overhead camera, I could chuck a bit of paper down here and draw some diagrams. That's probably a better solution. But a whiteboard cam would be a very cool idea. And some people use tablets and that sort of thing as well to draw on and then have it overlaid on the video. Yeah, so Austin's Creations said, I think the power supplies are ground connected. They look like generic eBay ones that are interconnected versus isolator type. Yeah. Austin's Creations, I assume your name is Austin. I'll just call you Austin from now on if that's okay. So Austin, you are absolutely correct. Yes, we have just verified that the V in negative and V out negative are physically tied together on the PCB. All right. Oh, Electron Ash said, currently trying to design a QSB quick solder board for a console in Eagle. So I'm here, but only in spirit. Okay, so Ash, if I keep mentioning your name, is that going to break your concentration? I'm sorry, did I break your concentration? And screw up your ability to design your PCB? Uh, Ash said, I've had sausage, bacon, and chips waiting in the fridge since last night. What? Okay, now, Henrik pointed out a very interesting point here as well. So, Henrik said, these modules only have a max load 3 amp if I'm correct, so maybe it's overloading the converter. That was my first thought as well, but it's not. One of the things that we can demonstrate that is that the flickering occurs when the brightness is turned down, which means that the current requirements are reduced, not when the current requirements are increased. And actually the reason that I have these two modules sitting right here is that there were 3 regulator modules running just that one word. So just the house board had 3 regulator modules behind it, and they were connecting to different parts of the PCB. So here in the PCB you can see that there are different 5-volt connections spread across it, and the 3 regulators were connected to the 3 different 5-volt things. So one of my theories was that these voltage regulators don't like being connected directly in parallel. They're often okay if you have the same common ground, but if you then connect their positive outputs together in parallel, so basically it's taking 2 modules and just putting them directly parallel and bridging across their inputs and bridging across their outputs. So in theory that gives you, instead of 3 amps and 3 amps, it gives you a total of 6 amps available. But there can be some bad interactions with switch mode power supplies, because they are sampling their output in order to adjust the duty cycle internally. So they've got an inductor on them, and the way these work is that they act as a chopper circuit, and they top up the charge in the inductor by adjusting their duty cycle, and they change the duty cycle by sampling the output side. So if you've got 2 of them in parallel, their outputs can interfere with each other, and then you can have bad things happening. So that was one theory, was that we just happened to have an unlucky situation where we had 3 voltage regulators connected in parallel, and their outputs were interacting in some way. So the reason I removed these 2 is I changed it from using 3 voltage regulators to just 1 voltage regulator, and I checked the supply rail and it stays rock solid on 5 volts, doesn't have any problems, and you can see it flickering now. That is with the brightness turned way down. So the amount of current that it's pulling is actually very, very small. There is no way that it's getting near the limit of that regulator. Yeah, so Henrik said, do you have an oscilloscope? Try to measure the voltage ripple of the brightness is down. First measure the dimmer regulators and then the brighter flicker regulator. Yeah, so checking this on an oscilloscope is I really wish that I could pull the scope screen up. That is something that I need to figure out. So I've got a Rigol scope here which has, it has an HDMI output, which means I could run it into a video capture device, and then I could feed that into OBS and I could stream my oscilloscope screen. I need more HDMI capture devices. I need one for the scope and I need one for a whiteboard camera. Alright, I'm not going to try to do that right now because it would be, I would spend the rest of the live stream messing around trying to set things up. But yes, squirrel alert. Yeah, Frederick said, I'm convinced it's something with WLED. I saw multiple presets. Could it be that one preset has been activated on the segment controlling house? Yeah, so this is where I'm going. I have poked and prodded this. I haven't put a scope on it, but I've poked and prodded this. I've changed the power supply setup. I've measured voltages like all the way down the chain. Everything looks spot on. And there is that weirdness going on in WLED. And so the next thing I'm going to do, before I actually spend more time looking at the electronics, is I'm just going to get the latest WLED, which I think is 0.11.1. So this is currently running 0.11, and there is a very slightly newer release, 11.1. So I'm going to grab that and do a full clean software installation with no segments defined and just see what happens. Maybe the problem will go away, and I've just spent the last hour talking about something that isn't even really a problem, and we're chasing imaginary squirrels. But imaginary squirrels can be interesting sometimes. Anyway, yeah, might as well get 3 and have one. Talking about HDMI capture, Mitchell said, might as well get 3 and have 1 spare for the next squirrel. Yes, so I need 2 more right now, and who knows what's going to come up next. Yes. Part of my problem is running too many HDMI capture devices into this computer. I probably need a better way of dealing with it through OBS, or I'm going to start having issues. I did notice, I don't know whether you could tell on the stream itself, but my preview window in OBS, when I turned on those extra 2 HDMI capture devices for the overhead camera and the microscope, the screen started stuttering. I'm going to turn them off now. So, bye-bye video sources. And maybe OBS will have to do a little bit less work to be processing all the inputs. Mitchell said you need an NDI capture kit. NDI can run over a network, so limits the amount of resources required on your PC. Yes. Okay. Squirrels, squirrels, squirrels. You know that I'm going to be Googling NDI capture. NDI tools. Okay, what is NDI capture? NDI capture works seamlessly with NVIDIA-based GPUs to make your screen available as an NDI source on the network. Alright, I'm going to have to look into that some more. And I know that I know OBS can bring in network-based video streams like RTSP streams and things. So another option is that I just set up video sources that are like like security cameras essentially, and just bring them in over the network. But still, I think it's not just the capture that is the issue, it is processing the video streams that is the thing. But anyway, I really like the idea of getting video capture on my scope. That would be handy. We could look at some interesting things then, do some actual live hands-on things. All right. Okay. You know that thing you do when you spill a drink or something and just sit there for 10 seconds trying to process what just happened? What have I missed in the... can't you just grab the HDMI and the overhead camera and use that for... Yes, Henrik, I could. But I'd have to pull the scope out. It's... oh, yeah, James said, get an ATEM Mini Pro to handle camera switching. Yeah. That would be nice. So the reason it's not just a matter of pulling out the HDMI cable and plugging it into the scope is that I have everything kind of stuck there. Let's see if I can bring up a camera view. Where is it? Droid cam. Yes. Okay, so 2.5 IP address of .252. Let's see if my camera setting is still working. And Droid cam. Oh, maybe I need to be... No, I think I need to be on a different Wi-Fi network. So I'm just going to switch. I'm on a restricted network at the moment, so I'm going to switch to a different network that hopefully will allow the... Yes, there we go. Okay, so now we have video streaming. And the frame rate is really low. This is making me seasick just looking at it. Okay, so I'm pulling back away from my computer now. So you can see where I was sitting looking at my computer, and just to the right you can see the workbench. So there is the microscope, and just up above it, I'm trying to move this phone very slowly so I don't make you all seasick. You can see the overhead camera up there, and the oscilloscope is right there, but everything is kind of stuck in. In fact, this scope is currently, it's blue tacked in place. It's sitting on the bench. I'm pulling it backwards and forwards and it's quite stable. And then just to the side of that, I've got a signal generator, and this is a wooden frame. So basically it's an enclosure for the signal generator with a spot to put notebooks and the if you don't measure you don't know device. And just to the right of that, I've got a multimeter, and this is also stuck in place. So it's just a handheld multimeter, but on the back of it I've put some little L brackets and I've glued them onto the enclosure, and then that is stuck down to the shelf. And what that means is that I can just, I can reach up and turn the multimeter and, change leads and things, press the button, and it doesn't go anywhere. And then I've got the LED power supplies over here. These are stuck down as well, so once again I can push them, so I can press stuff on the keypad and it doesn't move. So on my workbench, a lot of that stuff is actually stuck in place. And to get to the HDMI port on this, I'm going to have to pull this out. It'll take a little bit of rearranging. I can do it, but it's just not something I'm going to do right now on the live stream. So I'll just pan across to the right, and there you can see the flickering display. Because of the depth of field on this is much deeper than with the other camera, you can see the outline of the word super a lot better. And yes, so back to here, and time to switch to front view. Okay, how do I get out of this? Come on, what is going on with my phone? Now that it's in the Droid Cam thing and it's streaming, it's bright. What? I can't even see what's going on the screen. Okay, that's it. I'm out of it now. That's better. Point the Droid Cam at the scope. Yep, I could do that. All right. Where are we at? Yeah. So. Okay. I'm just scrolling back to see what those comments were. So, Electron Ash said, "I spilled half a pint of Coke earlier with scotch in the workshop room. Fun." Yes. Don't do that. That makes a mess. Alright. No, Aaron, we don't want the stream to die again. Sorry, this is going to be boring for a few seconds. I'm just trying to catch myself up on comments. And, Mitchell has just added a reference in Discord, which is cool. Thanks, Mitchell. A reference to HDMI to NDI encoders, and that will be very useful. I'm going to open that in my browser right now so that it's there, adding to my big list of network tabs. Ooh, oh, those prices are scary. $500 for a mini HDMI to NDI encoder. All right. I will look into that, but that's a lot of kangaroo bucks. Right, so cool. And there was a message from Andy a few minutes ago asking if I'm brave enough to take the sign down and start doing some diagnostics live. I'm kind of heading in that direction. This is not at all what I was going to talk about on this live stream. This whole thing was just, oh look, the sign is running and it's flickering. and now an hour later I'm still talking about it. What I was actually going to do was a little bit more of running Arduino lint to show you what I was trying to do on the stream last week. Yeah, okay. So, NASA Blue Tack. A couple of people are asking about the oscilloscope. So, yes, it's a Rigol. It's a DS2072 with all of the software updates applied. So it's got, I think it's actually 200 megahertz bandwidth, whereas by default it's, 70 megahertz. Yeah, it's one of those things where Rigol produce a number of different scopes with different features, and they have a different label on the front, and they have different limits. When you turn them on, you can turn the frequency up to a certain thing and it just stops. And it turns out that the electronics is exactly the same. So it's actually, this is an old scope. In fact, you can't even buy this one anymore. It's out of production. But I think this scope had the same electronics. It was physically the same as a 200 megahertz. As a 200 megahertz scope, but they limited it in software. So then you would have, you'd pay less and you get lesser frequency range. But if there was something you could do, and like you put I think it was a firmware file. You put a firmware file on an SD card and you stick it in the scope and you boot it, and then it boots up as if it's the higher model scope, and you get all of the extra features and all the bandwidth. So that one is running as with everything turned on. It's got all of the protocol decoders and all those sorts of things, and the extended frequency. Yeah. Loving the squirreling. Yes. Matt's head got inserted the squirrel of LEDs to prevent you breaking the internet with Arduino lint. Yeah, maybe I should. Oh, this is an interesting idea. Yeah, I have thought about this. David Howes suggested, how about a simple... So this is getting back to the whole video capture thing. So we're chasing a squirrel from a squirrel right now. Right now what I've got is a separate video capture device for each of these cameras. So there's one for microscope, one for overhead, one for front camera. So I'm running 3 HDMI capture devices right now. But another option is to use an HDMI switch and have one HDMI capture device going into an HDMI switch with multiple sources, and then you can just switch which camera you want to select from or which source you want. And that actually may be a really good solution, as long as I can pick sources that I don't want to show at the same time. So, for example, when I switch to overhead, you're not going to get it right now, but I'm getting HDMI capture off because I turned off the overhead thing. I'm getting HDMI capture from the front camera. It's doing screen capture off my desktop and HDMI capture off the overhead. So I'm actually running 2 different HDMI captures simultaneously to get that view. And I'd still want to be able to do that. But there are situations where there are 2 sources that you never need to use them at the same time. And in that case, an HDMI switch is probably a great solution, because HDMI switches are reasonably cheap, and it doesn't add any overhead in terms of decoding the video stream, because it's only getting one stream. It's just switching between different sources. So that is a really good suggestion. Thank you very much for bringing that up. So yeah, I should probably get myself an HDMI source. Oh, James said that's the ATEM. Yeah, but I think the ATEM Mini Pro is way more than that, because it's basically like an embedded computer. It does picture-in-picture and a whole lot of other things. And also, they're pretty expensive. How much is an ATEM Mini Pro? They're like many hundreds of dollars. ATEM Mini Pro. Yeah, they're like $900. 859 a video. Yeah, that's a lot. Where, let's see how much Blackmagic have them listed. Well, Blackmagic themselves list it for $945. Yeah, I could buy another camera for that. I think just a simple HDMI video source is. And he just said, face it, it's no longer your live session. The audience and live chat is in control, just like the Truman Show. Yeah. I have totally lost control of this live stream. I don't know what I'm doing. Yes. Yeah, okay. Matt, you're right. So I can't do picture-in-picture with an HDMI source. So if I need to do scope and whiteboard at the same time, that would be a problem. But I do think that an HDMI switch would be a good partial solution. I would still want multiple HDMI capture devices. So I'd probably continue with the 3 that I currently have, but then I might be able to, like, what would we never want at the same time? We'd never, well, maybe we'd want it all. I never want the microscope and the overhead at the same time. So I could put those on the same capture device with a switch, because if I've got a device, if I'm moving something between the two of them, you can't see them. You can't actually see both cameras at the same time. There's no point. So typically what I would do is have the side camera or front camera and one of those. I could combine those onto a switch, and then I could use the third HDMI capture for the oscilloscope, because one thing that we would want to do is show the oscilloscope at the same time as the overhead camera or the microscope, because we'd want to be able to see the traces on the screen and watch what's being probed at the same time. That's very useful. Talking about probing, and no, I'm not talking about alien abduction. I got a really interesting thing during the week. I ordered it a couple of weeks ago, and it just arrived. I haven't actually put it together yet, but it's a frame. I'm going to do lots of hand waving here. It's out in the garage at the moment in pieces. It's a frame that allows you to put test probes onto a board and then leave them in position without you touching it. Now, I did that video a while ago. In fact, I've got this test. I've got this test probe set up, and I've got. If I can get it down without knocking everything else. So I've got this. This is a steel base, and I made versions of the test probes with a magnet in the bottom so that I can just go snap and it just stays in position. So what I can do is, and I've made PCB mount things as well. So what I can do is put a PCB on here and then move the test probe and stick it on, and it just maintains connection. And then I can connect that to an oscilloscope or whatever device I want. So I do have a couple of these other test jigs, but this design looks really interesting. It's basically a frame with a clear acrylic plate with a whole lot of holes in it, and all you do, and it's got test probes that look like pens with pogo pins on the end. So you just sit them down through the holes, and gravity just holds them. They just rest on the board that you're testing. And so oh, hang on. EV blog showed it. Mike Brown said, oh, cool. Okay, I missed that one. I did not know that that Dave had already shown that one on video. I'll have to check that out. So I've Mike said, this is an interesting idea. Mike Brown said, you can display the scope directly on your computer over the network. Yes, I'd forgotten about that. The oscilloscope has an Ethernet socket on it, and you can run software on the computer that talks to the scope and shows you everything on the screen. And that way I could just do screen capture. So I wouldn't even need a device plugged in. I wouldn't need to do HDMI capture. Ah, okay. Yeah, SIGROC and Pulse View. Yeah, I'm going to write notes to myself. You lot are too full of good ideas. So you're giving me a to-do list. Okay, things to look up after the live stream. It is Rigol screen capture, which could be software or HDMI, and NDI capture, and what else was there? Oh, whiteboard camera. Although, yeah, thinking about it more, I think the sensible thing to do would be to just utilize the overhead camera more and draw diagrams on here. What else? SIGROC DS2072. Thanks, Mike. So SIGROC DS2072. Brilliant. Aaron said it allows you to, excuse me. Okay, hopefully that's better. Aaron said, allows you to stand up for health reasons during your 2-hour streams. Yes, I might get deep vein thrombosis from sitting here. Make your desk out of a whiteboard and draw on the desk. Well, I could do that. You can't see it right now, but this... So my desk is yellow tongue floor sheeting. So I made this just by attaching pine frame, like strips, to the walls. And then I cut this out of floor sheeting and then painted it all gloss white. So the entire workbench is actually gloss white enamel paint, and it's quite hard and smooth and shiny. So I could just write on this with whiteboard markers and wipe it off. It wouldn't be a problem. Yeah, all right. And someone just oh, Pancake Legend, you're here. Hey, Andrew. All right, going back, so Matt said, I also need to know why the toaster is there. Yeah, I mentioned that right at the start of the stream. That's because I was filming a video about 2-year conversion to Tasmoda, and I was using the, I was just using that as a prop, just holding it up in front of the camera and talking about it. So, yeah. Stogie says, maybe plans to laser engrave a Superhouse logo onto the toast. One of the first things I did when I got my laser cutter was put a tortilla in it and use it to cut out a dinosaur, a dinosaur shape out of a tortilla, to entertain my daughter. And somewhere around I've got a photo of it. I'd have to look around, but it probably actually wouldn't be that hard to find. Photos? No, I'm not going to go digging right now. But I do have a photo of a tortilla which has been laser cut with a dinosaur shape. Yeah. So, I need to refocus myself. What is the point of these live streams? I don't even know what I'm doing. I'm just rambling. Okay. So, RCX said the first 3D prints were given to the kids. Yeah. Okay. Mako said going to the electronics room, so see you all. Bye, Mako. Thanks for hanging around for a while. Yeah. Okay. Oh, all right. Matt said they're pretty enjoyable though, these live streams. Thank you. I don't quite understand why, but That's somehow they still end up being fun. Fun for me anyway. Hopefully fun for everybody else. Okay. And Pancake said, chat is still an AI simulation. We're here to aid you with your recovery. Yeah, so Andrew, are you just GPT-3 sitting there on a virtual keyboard? Probably. All right, so you haven't been seeing it, but I've been sitting here. Ooh. Bribe or donation, Andy just said $5. Bribe or donation to focus on solving RGB LED sign problem in the next 40 minutes. I have 39 minutes left. John's Internet of Squirrels. Okay, so, all right. I can be bought for $5. Let's work this out. All right, the Matrix has you. For $5, I will try to solve that flickering LED sign problem in the next 40 minutes. Okay. Clear the decks. Ooh, Johnny just put in 50 sec as well. I looked up, I was really curious, and the thing is that I don't actually get this whole thing about sec. I know that whenever I'm watching other people's live streams, people keep donating in SEC. And I did look up what that was a while ago. It's a currency. Oh, James has doubled down. US $10. Thanks, James. So what is SEK currency? What is it? Okay, it's a Swedish krona. And let's say 50 SEK to AUD. It's $7.78. Okay, cool. I've seen a few people donating in SEK, and I don't know why. Is there a reason that people choose to use that? Is there some Electron Ash? Okay, maybe that's not. James said, I'm not working on the sign. Yes, I was chasing currency squirrels. All right, I'm clearing the deck. I am moving stuff out of the way. And what I'm going to do, I will actually be kind of disappointed if this works, but what I'm going to do is grab the sign, bring it down here, reflash firmware, and see what happens. So, let's try it. Okay, power is disconnected. I have the sign. I'm going to need to turn on my overhead video capture again, just in case I need to do that. But, alright, so, I've never actually flashed WLED. Let us find out together what is involved. And I'm going to save. No, I'm just quitting out of Eagle. And Mike suggested power directly from your lab power supply. Yeah, so that's one of the things is I could bypass all of those voltage regulators that are on it and run it straight off a lab supply. Now I've got to get out of Keynote because I had that presentation open from earlier, and Pancake Legend, thank you for the $5 gauntlet thrown. Alright, now, what do we have here? Let's come back to, come on, switch, my scene switcher has stopped working. Oh, there it did, it worked eventually. Alright, so we have here, okay, so just flash the bin file, Tasmatizer or ESP Home Flasher will do. Awesome, thanks Aaron. So what I need to do is grab WLED and I will just grab the binary and run Tasmatizer. So I need a USB cable and I should have plenty of them right here. And turn this over. Can I get to it? Yes, I can. Okay, that's a relief. I thought maybe I wouldn't be able to get to the USB socket on this. And, oh, might need a different USB cable because there is not much room. Oh no, it fitted in. It's not much space there. Okay, so let's have a look at releases. Where are we? On this page, tutorials, somewhere. Okay, quick start, wiki, which I think just has a link to the binary, full release binary. That's what I want. And then what happens? Did it do a download? Nope. Okay, ESP tool, and where am I looking in the right place? Where do I download it from? That's what I want. Download the latest release binary file. I thought that was the link I just clicked on. Alright, so I want, which one? The basic one, I guess, ESP8266 bin, and let's grab that one, and I'll just go back to the tutorial. And he said, can moderators turn off John's chat so he focuses on the resolution? Alright, I will I will try to avoid looking at the chat, which means you can't help me, which is sad. So now somewhere down here, alright, it had back here it had an explanation, and I want this one, I believe. LED pin is GPIO2 in this case, so just the regular ESP8266 bin, which is the one that I just downloaded. Alright, so where is, pull up a terminal, where do I have a Tasmatizer? Looks like I do. Come on, Tasmatizer, do your thing. Where are you? Has it launched? I can't see it anywhere. Okay. Is it just because it's off? There it is, it's hiding in the background. Oh, stop that. Alright, so Tasmatizer, what have we got? I haven't plugged anything in yet because I wanted to see what port it comes up on. So I'll plug that in. Ooh, there is a squealing noise. I think because it's trying to power the LEDs. Okay, 14440 bin file. I want to grab the download. Where are we? Downloads. WLED. That's the one I want. And erase before flashing. Yes, let's do that. And let's just Tasmatize. Go, go, go. This should, yeah, because it's got erase before flashing turned on, this should remove any of the existing configuration. So I'll need to link this back into my Wi-Fi and do all of those sorts of things. Writing. Okay, while it's doing it, I will look at the chat. Okay. Isolate the problem, third block, and yeah, simple test with known controller and software. Okay. Yes, so we're going to reflash it and see what happens. Check as your WLED may have over the air. Yeah, maybe it did. But I wanted to do a full clean reinstallation, including erasing the flash, because I wanted to make sure there was nothing existing from the configuration so I could start again. Okay, so we now have it flashed, and alright, I'm going to actually, one thing that would be interesting is I'm going to run this off my lab supply into the input that goes to all of the onboard voltage regulators, because at least then I will be able to see how much current it's pulling, even if it's not using the lab power supply for providing the regulated voltage. Oh, except that I can't. Ah, this is it's a 2.5 millimeter DC jack, not a 2.1 millimeter, so I can't actually plug that in. All right, let's plug it back into its normal power supply. I'm going to switch this back over here and see what happens. Back to its normal power supply, and I assume that this is just like default behavior, that nothing comes up. Oh, it's booting, okay. So there's something happening there. Put it back up there, and then I'm going to need to use my phone to reconnect to it. So hopefully right now it will be advertising an SSID that I can connect to, and I don't see one. So somehow remember my presets. Okay. Come on, why am I not seeing it? Unless it's ESP, is it that? Does it just come up as ESP, or I thought it would come up as a WLED type network? Install the binary. Alright, I thought the network would be called WLED. Yeah, WLED AP. It's not coming up. I don't know what's going on. It's not doing anything. Okay. I do want, instead of having it all the way over here, I do want to have it over there, which means I can either move that. Let's see what else I can find. I might have another cable, 2.5 millimeter DC plugs into it. Yes, I've got some down here. And this may end up as a bit of a yak shaving exercise. Oh no, that's just sockets. It's not plugs. So I could make up a cable specifically for this. Let's see if I've got a 2.5 millimeter DC plug over here. I may have. Doesn't look like it. Okay, let's just relocate this power supply. Bring it over here. This way I can get the multimeter on it and maybe the scope and see what's going on. Oops. Alright, let's try again. Plug that in. And I now have the single digit that is illuminated. So I actually have a feeling that maybe the cable was just falling out of the power supply earlier, which is why it was doing that. What did I just do with my phone? It's over there. So now we should, if that is working, we should get a thing that we can connect to. Yep. I'm still not seeing a WLED network. I wonder if my flashing didn't work properly. I might have nuked it. Interestingly, when you have a WLED Now there is actually a thing on here which I don't recognize, which is an ESP network. I wonder if that's it. I'm just going to switch to it to see what happens. So it might not be coming up as WLED. Okay, switching. And alright. What have you done? Using it, it should be. Scan this QR code. Okay, let's see what this does. Connect to this network. But that network doesn't exist. Yeah, for some reason it is not coming up. Oh, I wonder if, as you said in the, yes, yeah, it's probably still got the settings in its Wi-Fi. In fact, it might have come up on my normal, oh no, it's worked. My phone is now connected to WLED AP. So let's see what we can do from here. What's the IP address? I've got to get to, I think it's, what is it? 10, IP of 4321. Okay, 4.3.2.1. Go. Hey, it says welcome to WLED. So I am actually connected to it now. Wi-Fi settings. Okay, network name. I'm going to connect to my normal network. And network password. I'm doing my best not to actually say the password as I'm putting it in. Leave all of that, save and connect. Now, Wi-Fi settings saved. Okay. So, now I'm just going to see if it's come back up on the same IP address on my normal network. It has. Ooh. Okay, I'm going to switch you back to the desktop so you can see what's going on. Alright, and ideally we need this somewhere that you can see it as well. So, where can we put it? Over here. Is that safe and in field of view? It's just in the field of view. Once I move my chair, it should be better. Yep, so you can see the sign. I'm going to move it back out a little bit. There. Alright, so now we can see the sign and we can see the UI. And it says you have no presets yet. However, there's a backup preset data of a previous installation available. Alright, just for the fun of it, I'm going to copy that to the clipboard and I'm going to, what am I going to stick it in? I'm going to stick it in notes, just so that I have it in case I need it. But part of the point of this is I wanted a nice clean installation from scratch. So I am not going to save a preset. I'm not going to, reuse the existing one. Let's just try, what is the most basic thing? Solid. No, config. We've got to change the number of LEDs. No, not Wi-Fi setup. I want LED preferences. LED count 30. So the LED count is actually, I had this written down earlier, 385. It says max 5 volt 22 amps. For most effects 8 amps is enough. Yes, okay, so I'm just going to leave everything else default, I think, unless there's something weird going on. Is there anything strange in the defaults? I don't think so. Probably the default color order, default brightness, apply preset, so 0 uses default. Transitions, crossfade, brightness, I don't know, I'll just leave them all as defaults. Change that. And look at that, we got some flickering going on. That's interesting. So, where are we? I'm just gonna, should show orange if okay. Some call it fun. Said, yeah, same problem. Okay, now, oh, James said, I also saved the segment info if you need it. Oh yeah. Doctor said we can lip read the password. The password is just password. Yes, not quite. You got to add numbers as well, so it's and do it in leet. So the password is actually P4. What is it? P4SSW0RD, or maybe P455W0RD. What am I doing? Okay, so what we've got is the same problem. I'm just to confirm this, I'm going to turn the brightness right down, and I'm going to try with the brightness up a bit as well. So you can see that the end area is flickering in a bit of a strange way. And let's change color to blue. But if I turn the brightness up, let's see if the flickering gets limited to the end. Still flickering. All right, let's try a different effect. Ooh, this is going to be interesting because it's working its way along, and you can see as it gets towards the end, the flicker begins to occur. And the colors go a bit crazy as well. It's no longer just blue. All right, well, so we're back to a default setup, and Matt said, can you power this thing from a basic Arduino sketch using fast LED library, then Adafruit library? Yeah, oh, Mihu said faulty LED. I was wondering about that. But the thing is that there are so many characteristics to what's going on here that just totally throw me off. And one is that the position at which this effect begins changes depending on the brightness level. That little thing just totally messes with my mind. So I'm going to change this back to solid so it's all on. In fact, let's go back to front camera so you can see it a bit better. You can see that the weirdness is going all the way to the start of house there. Now if I turn the brightness up a little bit, you can see that it doesn't really go into the H. I'll turn it up a little bit more. It takes a while for the thing to scan across. Oh, it's doing all of the H. Maybe I have been chasing, maybe I've been thrown off the scent this whole time because the behavior is not what I thought it was. So you can see that the weirdness comes to around this area, and the furthest it gets is about here. And if I turn the brightness up a bit more, then, oh, it does still go into the H. That's interesting. So it still makes it to this point. You can see that most of the effect is over towards the right, but it is still coming across. Now if I turn the brightness up more, it does still come part way across. Which suggests some kind of an issue somewhere around the center of the H. Okay, so yeah, Matt said, I'm convinced it's power related as Scott says. But looking at it now, I thought the position was changing when I was doing this before. Maybe the position has not been changing. I've just turned the brightness way down. It's down to like 5% or something. So these LEDs are just barely on, and these ones are coming on more. But the it is coming across further than I noticed before. It is coming across into the H, even at the lowest brightness level. So, okay. My next, the next thing that I would do in this is, so Johnny said the buck regulator doesn't like to be low powered. No, I know what you're saying. So what Johnny's referring to there is the input to the regulator. If it goes down below a certain point, a buck regulator will drop out and it'll start doing strange things. But in this case, they are getting a constant 12 volts input, and it's the illumination is being set by the PWM inside the LEDs. It's not being set by the voltage that's being supplied to it. Yeah, so what I'm going to do is I'm going to take the output from the D1 Mini that is currently going into the start of the word super. So it's currently going the data is being injected right there into the start of the S, and then it's following along the chain all the way through, and then through the logo, and then from the logo it's going out and then into the word house. What I'm going to do is take the data line that currently goes into here, disconnect it, and connect it all the way across here directly into, or maybe I'll do it into the start of the logo. So basically I'm going to take the word super out of it, inject the data further along, and see if anything Matt said, if the soldering iron doesn't come out for this live stream, I'll eat my hat. Hang on, I just got to do something. Computer, turn on the soldering iron.
Okay.
Done. I would not want Matt to have to eat his hat. Yeah, so what I need to do is grab the data D2. Okay, so data line 2. Now, unfortunately, you're not really going to be able to see anything much here. I've got to find the data entry point. It must be being breached across on the other side of the PCB. All right, I'm going to have to pull up Eagle for a moment and give myself X-ray vision to see what's going on here. James said, "Oh God, you get to see the mess." I was being a little bit hesitant about showing the overhead camera. I don't necessarily want to reveal someone else's work. So projects, Eagle, archive. Where? Okay. Sorry, I'm just scrolling through many design files here. Okay, so we've got we're coming in from that corner on the word super, and then where is the inlet? It must be being breached on the other side of the PCB. So James, you can probably confirm for me that I may actually not be able to do this because I actually can't fully disassemble this. I can only see part of the back of the PCB and I can't get access to anything else. It's glued together, like everything is glued closed. So if the data lines bridge across on the other side of the PCB, I can't get to them, which will be interesting. Now, what I can do though is that trick I was talking about earlier. Okay, yeah, we can do this. All right, Superhouse logo board. I'm just going to pull that up. We can do a little bit of PCB surgery here and inject the data in a different location. So if we switch to this view here, all right, so you can see this is the central board. And I'm just looking for the one that is closest to the end of the chain. All right, down here. Nice. So this, if I can highlight it. Okay, so this point here. Here we go. So this is a track on the back side of the PCB. The blue is the back of the PCB, and that's what I can see. And that is a data line. So data out coming from this LED going to data in on this LED. So because I can get to the back of the PCB, what I can do is cut this track and inject the data at this point. And that effectively will have moved our source of the data from the beginning of the chain to like past halfway along the chain. And let's, oh, if I can get to that part of it, because there is wood frame across this. I may not even be able to see that part of the PCB. No. Okay. I'm going to have to look on here to find. So, James, do you mind if I show this, or would you prefer I didn't? I don't mind either way. I'm quite happy to keep this view off camera. Just removing some glue. So what I need to do is find a piece of the PCB where where one of those tracks goes across the back. Now, is there one somewhere near the... Oh, there's one sort of in the middle of this PCB, just here. So if you look at that, oops, at that track, that is nearly in the middle of the PCB. It's just up a little bit from center. I should be able to get to that. But to do that, I need to lift a couple of voltage regulators so that I can move them out of the way. Let's see what I can get in here. Ooh, okay, that nasty cracking sound was just the glue letting go. I'm just... this one doesn't want to come off. So I've got one of the... I may only need to move one. I'm trying to move the voltage regulators that are currently on the back of the PCB so that I can get to that track. Here we go, making some progress. It's removing it. Getting closer to it. Sounds like I'm totally butchering it, but I think it's okay. Now, where is that track? Somewhere on the back of that PCB. Oh, there it is. Okay, I can see it. Very good. Yes, we can do this. Now, Mihu said, not sure if it will work after you inject the signal with previous LED still in circuit. No, that's going to be okay. And what I'm going to do is actually cut the track on the PCB so that we're isolating we're basically going to take a string of LEDs, which is what we currently have, and we're going to cut it in half and inject the data part way along. Sorry, I'm just doing a quick check on comments. There's another bottom trace in the middle of the @ sign. Yes. Yes. Just checking. Is a cap missing? There are no caps as far as I can see. So I don't think there are any capacitors on any of these. Oh, Lee said you could do with a moderator in a voice call with you to relay messages from people in the chat. Yeah, okay. So what I was just doing was checking whether it is okay. James hasn't said anything for a while. I'm wondering if James thinks it's okay for me to show this. Alright. let's see what we can do. I'm just going to bring the microscope over so you can see part of a track, and drop you to microscope view. Is it? Yes, it is working. Okay. So what we're looking at here, if I get some focus into it, there we go, there's some focus. So that little track that you can see right there is, if I switch back to desktop view, this track right here. That little dogleg sort of thing. In fact, if I'll flip the PCB so that we're looking at it from the back side of the PCB, and that track there is that track right there. So what I can do is grab my trusty scalpel and try to keep everything out of the way, and I can come in here and do a little cut. I'll try to do this without getting a shard of copper bridging across to the 5-volt plane, because that would not be ideal. Well, let's get some zoom happening. We're way too far out here. Get the position a bit better. I'll focus it for the camera, not for my eyes. So I'm looking at it a little bit out of focus at the moment. Okay, so we now have a nice isolation in the data line, and where I want to go in, D out, D in is the one in the top right. So, oops, not that one, that one. So the via in the top right is D in to the rest of the chain, and so I want to patch data into there. Good. Get that off. Should have cleaned up my soldering iron tip before doing that. It's looking pretty gross. Right, so I want data in to go there. And at the moment, data in is coming from D2. So you can't see this because I'm off to the side, but I'm just going to pull the data wire off the D1 Mini, grab myself a chunk of wire, how much do I need? A fair bit actually. It's, in fact, I'll make a long bit of wire because I want to I might want to inject further down in a moment. So I'll make it long enough that I can reach all the way down the sign. Turn on my little extraction thing, which makes a nasty buzzing noise, but it pulls the smoke out of my face, which is always nice. Alright, so I'll connect this wire to D2 on the D1 Mini. And then, can you still see the microscope? Yes, you can, just. Alright, so I'll bring this one in here, solder it on. Hopefully the solder mask is doing its job because I've got this wire directly on top of the solder mask. Okay. Now let's see what happens. So now we have data injected at that midpoint of the sign. I'll turn this over, bring it back over here, and I'll switch cameras in a second so that you can see everything. Apply power again. Ooh, interesting. Okay, so what you can see is the pure orange, and this is very interesting. So what we're doing is injecting data partway through the @ symbol, and now I'm going to go to, what am I going to switch to? I've got to switch back to WLED, And so, yep, you can still see it, just. Okay. Now, I'm going to turn the brightness down. Let's see what happens. It's working. Check that out. That's really interesting. So I'm going to switch it over to blue. And I've got the brightness turned way, way down. And I'll switch back to the other camera so you can see it a little bit better. And we've got no flickering. It is working. Yeah. Alright. I'm slightly baffled. Now the interesting thing here, I'm just thinking about the next step from this. So what this indicates to me, I'm going to turn the brightness up. In fact, I'm just going to mess around with it a bit. I'm going to try different things, different effects, just to see if it all runs. So that's with brightness on maximum. That's with brightness on minimum. I'll turn it up so the brightness is just enough that you can see it. Somewhere around here. Yeah, around there. You can see that. And you can see that this is working flawlessly. I'm going to change the effects to Android. Alright, it's now doing the effect that was totally failing before. And I am going to... Okay, what I'm going to do is move the injection point back. Not to the start, but a bit further back, and see what happens. This is very interesting. In fact, what would be interesting would be to take the output of this word and feed it back in to near the start. That would be very, very interesting. Yeah, Andy said, need to gather evidence from the oscilloscope, etc. while the problem is occurring. See whether the data in for the first LED on the third block looks the same on the last LED on the third block. Yeah. Okay. So, what do we... right. I'm going to... Because this is actually a reasonably easy thing to do, the next thing I'm going to do is move the... Oh, interestingly, you can see that it's gone blank here. That's because this effect, it thinks it still has 385 LEDs connected, but it only has this many. So it gets to the end of this point, and then it's off in fairyland somewhere in with LEDs that aren't actually connected. So what we can do is take the output from that word and inject it somewhere way back up the chain. I'm going to go as far back as I can. Let's switch back to here. And like Phantom Leg, yes, exactly. Peter said, my money is still on John having broken it. Yeah. I think that's quite likely. Alright, now I'm going to load now the word super. The super board. I want to find the point the furthest up here, closest to the start, where I can inject. If there is anywhere, there may not be any in this particular PCB. There are some in the U. Okay, so there's one here. I could inject at that point, because the thing is I can't actually access this part of the PCB up in the top corner. That part is covered by the wood frame, and I can't get to that particular thing. So what I could do is inject the data back in at this point, and but before I do that, where is it? Back over here. Okay, but before I do that, I'm going to do something else entirely. I'm going to remove that data line and feed it back into where it was originally going. Now, this is a bit of an A/B testing thing. So what I just did right then was I soldered the line back to the original injection point because I want to see if the problem... Oh, of course, I've got a bridge across that track. Back over here. Alright. Because what I want to do is see if the problem comes back. Now, you might be wondering why I would do that, and that is, and you would be thinking, of course it's going to come back because you're just switching it back to the way it was before. But, yeah, I'm on the wrong camera. Let's switch back to here. But the thing is that when I'm doing tests like this, I like to be able to revert to a previous state and validate that the change you've made has actually had the effect that you expected or not. So, what I'm going to do is, so I make the change and see the change and then undo the change and then you see it go back to doing what it was before. And it's just a way of proving to myself that the thing that I changed did change the thing I thought I changed. I'm not making a whole lot of sense. Maybe you get what I mean. Maybe I don't make any sense. Okay, so that data should now be back bridged again. Switch back to here, and yes, I am aware that I have now blown my time on this. I failed to fix it within the 40 minutes. All right, turn that back on, and it's bright. There's no flickering at all. But I'm going to switch back to WLED, turn the brightness back down, and see if the flickering occurs again. Come on, turn down. Oh, I've got to reload the interface. Brightness. What is going on? It should be orange. Why is it all green? Let's change. Oh, there we go. And brightness turn back up. Brightness turn back down. Why isn't the brightness turning down? Oh, there it goes. And there's no flicker. Oh, I saw something. It just did something strange. All right, now I'm going to change this to I've got to change the color. All right, solid. Let's try changing it to Android. What's going on with this? I'm changing things in the UI, and I'm not seeing changes in... Look at that. Oh, no, there is a little bit of flicker there. All right, I'm going to change it back to solid. And brightness down, brightness down. Change the colors. Why isn't it changing? It's just staying orange. Well, it's gone. It's actually red. I have changed all the colors on this to be blue now, and it has not changed. It is doing weird things. Back to the Android effect. Like, it's taking a really, really long time from the time I click anything in the UI to when anything happens. And now nothing is happening. Loading UI. Come on. nothing is changing. So I'm going to power cycle this. I don't know whether you can, you can't tell because it's so glary, but there is one LED that I can see just up here that is blue when everything else around it is green, which is a little odd. Now, back to bringing up the web UI, bring the brightness down. Come on, are you going to respond? Back to solid. I've got the brightness turned way, way down now, and it is not coming on. What am I? Ah, my mouth is not engaged properly. Yes, Peter said yes, I did break it. I have a feeling that this might be that the data is not coming from the WS2812 properly with that big dodgy wire that I just connected. It's quite possible that what's happening is that the data line, see, it's just changed now. I'm touching it with my hands now and it's changing. I'm actually influencing the data that is being sent by physically touching it. Now, I'm kind of tempted to add a level shifter into it because I suspect that we're actually dealing with multiple things here. And what might be happening is that voltage offset that I was talking about earlier, the output from the D1 Mini is 3.3 volts, and it's marginal on the spec for going into the LED. So I think what might be happening is that now that I've bodged those wire connections, it's enough that it's not connecting properly. So I'm going to undo that. Let's pull this, and I'm going to remove that bodge wire that I just put on a second ago. Take off that. Sorry, you can't see what I'm doing right now, but this will only take a moment. And I'm going back to the original wire that was coming out of D2 and into the first of the LEDs. Back here, let's try it again without that big dodgy wire. Oh, interesting, I saw some flickering there again. Let's see if it behaves any better now. So I've just got to say, James, thank you so much for making this. This is awesome. It's been it's quite a cool thing in itself, but it's also just so interesting to play around with this. All right, I'm going to change it all to blue. Yeah, see, it's actually responding now, whereas it wasn't before. And I think that wire that I added, all I did was add a wire that goes from the output of the D1 Mini going to the input of the chain. And the wire was, I don't know, 400 millimeters long or so. And that was enough to stop the D1 Mini from being able to communicate with the LEDs. So all I did just then was unsolder the two ends of that jumper wire and reconnect originally where the wire had been, and now I can control it again. So I can change the brightness and change the colors. Let me see, I'll change it to that. See, I can change things and it's responding again. So it is responding, whereas it wasn't before. Now, okay. But one thing that is interesting, if you can probably see from there that the segments that are flickering do not go all the way to the H. They are now only the last few letters. So it's now flickering It's only occasionally, but it's flickering up to about here. Sometimes there, sometimes up to about here. Whereas before you saw very distinctly that the effect was coming all the way up here. So maybe I wasn't totally insane. Maybe the position was changing. I got to take a pause for a shot of vodka. Movie vodka, that is. You know, water. Yes. Okay. So, Jack's Tech said it really looks like power glitching after the buck regs. Okay. So, there is a way I can test that. It's going to take a little bit of messing around, a little bit of soldering. I am past time now, but I'm game to keep going for a while if you are. All right. Peter Lawler said, hey, nice water bottle, got any spares? Arnett. Yes, someone's been to LCA. I have, I think, 4 of these water bottles, thanks to Arnett. Game to continue. Yes, cool. Okay. Now, so the plan. My plan is to remove all of the existing voltage regulators and power the 5-volt rail off my lab power supply so that I can, Mike said, scope it, see if you need to pull up or pull down resistor somewhere down the line. Yeah, I might get to scoping it. In fact, I might, even if this works, I might just stick the oscilloscope on the data line in fact, what the hell, let's do that. Just out of curiosity, because it's kind of cool to see what's going on. So I'm going to leave this plugged in, and I'm not going to go to the trouble of trying to set up the oscilloscope software right now. I'm just going to, I don't know, I'll point my phone at the screen or something, as someone suggested earlier. Alright, so I need myself a ground connection and the data line. Now, where can I pick up ground? Somewhere handy. Where can I grab a ground? Let's... It's not actually as easy as it sounds. I'll just get a bit of the glue off out of the way so I can see more of the PCB. Oh, interesting. I can feel that this PCB is actually quite warm. In fact, I can even pull out the thermal camera just for the fun of it. In fact, the end of the board where the problem is occurring is noticeably warmer than the rest of it. The PCB is actually quite warm down in that area. That is curious. Alright, so where can I get myself some ground? Alright, I need I'm going to grab myself another alligator clip because I'm going to get ground from somewhere further down the board. Alright, I'm going to take ground off one of these V-regs and take data from there. I will get you all viewing run. Come on, scope run. Ooh, I'm seeing data flickering. I'll get you a view onto the scope in just a moment. I'm just getting things kind of vaguely sorted. Alright, so, whoa! Awesome! Smoke came out. That is amazing. Yo, this wire is burning hot. Look at this. That's insulation that's burned off the wire. How on earth did that happen? I've got to stop and think about that one for a moment. So I was connecting to... Oh, I know why. It's because I wasn't connecting to ground. I connected to... Oh, this is funny. I connected to the the 5-volt rail as the ground reference for the scope probe. So there was an actual literal release of smoke. All right, let's try that again. I'm gonna pick up ground from an actual ground point this time and pull data off there. Okay, so let's see what we've got and whether we can see anything useful on here. Oh, it actually smells a bit bad. I've got okay. Sorry, this is totally uninteresting right now because what have I got? 5 volts, 2 volts. I'm just messing around with getting some signal on here. All right. Why is that voltage going so high? True level 4.7. What? Yeah, this is not the fun part of the live stream. What I can see on the scope here is it looks like there is a data block that is showing up, but the voltage on it is unexpectedly high. And what is going on here? I wonder if I killed my probe or something. Oh. Okay, another stupid thing. My probe switch was in the 1x position, and I don't know why. They shouldn't ever be in the 1x position. And my my scope is calibrated for it on 10x mode, so it was showing me very high voltages on the data line, and that explains it. All right, so now it will start to make a bit more sense. I hope. Yeah, this is not the most interesting. I might just switch to changing the power supply over and switch to showing data later if, oh come on, if hang on, maybe this is useful. No, I'm just wasting time now. I'm fiddling around with the scope when I should be doing something more productive. So I'm going to put that aside. So my plan was to remove the voltage regulator modules and feed power directly from the lab supply. That's right, that's what I was up to. Alright, so what I've got is there is power going into the D1 Mini from one of these regulator modules. In fact, easiest way to do this, get out the wire cutters. I was trying to avoid this, but I think this is going to be the simplest thing. Now I'm thinking about grounds here because we also need a ground connection to each of the boards, and that is going to go away if I isolate these voltage regulators. Alright, so I think that is okay. I can do that. So I'm going to isolate that, 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 and that. Sorry, James, I'm I'm undoing all of your hard work here. But this is the quickest way to see if this is the problem. Now, how much do I want to isolate? So there's that. I've got to. Alright, I'm going to switch to overhead camera just so you can see something of what's going on. Overhead, and where's my little control? I need to zoom it. Zoom, 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 zoom. Alright, zoomed. Okay, so you're looking at the back of the sign here. So this is the back of the PCBs, and these are the voltage regulator modules. So power comes in here, and it goes to each of these regulator modules, and then those modules inject power at different parts of the site. Up here is the D1 Mini. It's a bit, I'll turn off the microscope light. There we go. So that's the D1 Mini, and that orange, no, which one is it? The yellow one. So this yellow wire here goes to D2, and that is the data, the data line that goes into the start of the chain of LEDs. And then these are all power connections. So the D1 Mini is getting 5 volts off one of these regulators as well. So 12 volts comes in here. It gets regulated down to 5 volts. So what I was just doing, while you couldn't see it, was I've just disconnected the outputs. These voltage regulators go to these power inputs onto the sign. And each of these orange ones is a 5 volt input, and the green ones are ground, or 0 volts. So what I was just getting to was I need to see where the D1 Mini is getting its power, because it still needs power. I can't run it without power on that. But maybe what I should do, so I was going to leave that in place. No, but what I think I'll do is, oh, there it is. So that's the 5 volts going to the D1 Mini. So what I'm going to do is isolate every one of these power connections, and I'm not going to use this power input at all. I'm just going to feed 5 volts directly from my lab power supply, so that I can see exactly how much current is being drawn, and we can make sure that it's regulating properly, all of that sort of thing. Alright, so ground there. Don't care about that one, so ground, take that ground out. And this one, now this is it's a bit of a large scale butchering job that I'm doing, unfortunately. So that one doesn't matter. And I think we are now entirely isolated. So we've got a couple of grounds there, we've got powers here, power here, there, power there to this one, and these are doubled up. So in fact, you can see how there are 2 greens there and 2 oranges. They actually just go to the same contact point. So what I can do is isolate. Come on. It's just a little bit too short for me to get the wire strippers in there. I might have to do it the old-fashioned way. Nope, that worked. Alright, so what I'm going to do is strip off connections here. Come on, didn't get it quite deep enough. And link them all together. I really only need 1 on each PCB, I think. So, because each of these goes to the same. Now that I'm not using the multiple voltage regulators, it doesn't matter about all the different injection points. I only need a single injection point. What I don't know though is whether these go to the same place. So let's do a quick test on that. They do, which means I don't need that one. And that is power to the D1 Mini. So that, let's see if that goes through to here. No. Alright, so this must be ground to the PCB. So we want ground. Oh yeah, that'd be it there. Okay. So that and that. Yep. Very good. Alright, so that is power to the D1 Mini. Then we've got, and it's also ground to this panel, we've got ground and ground. So we've got 3 grounds that we need to connect. And then we've got 4 points of power, because we have 1 point of power to each of the panels and power to the D1 Mini. So, now this is, I'm just thinking about the wire that I'm going to use here. I've got horrible skinny little wire. If I was going to do this properly, I would use something which is reasonably decent. But let's take, step 0 rather. Let's just tin these connections. And which one will I use? That one. Yep. And that one. There. And there. And there. Okay. So, I want to jumble them all together. These ones will reach. Stick those together. Doing practical stuff like this on camera is kind of a weird thing. I haven't even looked at the chat for a while. I've got no idea what you're talking about, if anything, or if I'm just here talking to myself now, which is quite possible. Let's get myself some things to hold this in place. What do I use? Maybe this. Stick that in there, and stick that there. This is a little 3D printed soldering jig. It's quite handy. It's just got slots on the side so that you can insert different thicknesses of wire, and it holds it aligned through. Now, got to add this one into it. Bridge from there to one of these, and then bridge it around the other way as well, and there, when I'm doing these live streams, my goal basically is to talk and to not stop. But it's remarkably hard to do that when you're... Oh no! I've soldered myself into position. Can I get the jig out with those wires soldered together? Come on, unhook, unhook, you can do it. What can I use to get it past that point? Maybe it'd be easier if I get this end off first. Yep. So that end off, and then I can get the jig out. Alright. Now, solder that and that together. Oh, my stomach is rumbling. Hopefully you couldn't hear that. My stomach is saying, what are you still doing at the workbench? You need to go and get lunch. Doing this one. Oh, come on. Nope. Gotta make the joint before I burn my fingers. Yeah, that looks alright. It's holding them in position. And yeah, so this little thing, it's a 3D printed solder jig, which is quite handy. I just grabbed this design off Thingiverse. So I need that, and I need this. Well, these two will reach together, which means that I can just bridge this to there somewhere. Now, this wire is actually a little bit thin for what I should be using. And if this display was being run at full brightness, I definitely would not be using just a single strand of this wire looped around to try to carry all of the current. But what we're trying to do here is not really eliminate a voltage drop situation. How am I going to do this? The jig won't fit in. I need to strip back a little bit more of this wire. Yeah, we're not trying to eliminate a voltage drop situation in terms of the VREGs not being able to supply enough current. The issue is at low levels of illumination when it's not pulling very much at all. Oh, come on. It didn't want to come off because I'd already tinned the end of the wire and there was a bit of solder on it. What I'm trying to do is eliminate the VREGs as a problem in terms of having multiple regulators connected together, possibly a dodgy regulator. I have to do this without using the jig because it doesn't fit in there. And I get everything in the same place at the same time with one hand. Maybe. That is a terrible solder joint. But hopefully it'll hang together for long enough. Alright, so we've got a common 5-volt rail there. And you can see that I haven't connected that one or that one, but that doesn't actually matter. These injection points, as I showed on the PCB earlier, are all doubled up. In fact, why did I include that one? It's doubled up with this one. It's all on the same PCB. Ah, well. I was too busy talking, not busy enough thinking. So let's bridge across the grounds as well. And then we can power it off the other supply. Yeah, so as I was saying, the main reason for doing this is just to make sure that it is actually getting a good clean 5 volts. Yeah. Even though it's at a low current. In case there was some weird issues going on with those buck regulator modules. Alright, so I've got ground to there, don't care about that, I need to connect to there and there, and these reach each other, which means I can do this with just a single piece of wire. Much nicer. So for anyone watching in Europe, this is probably a ridiculous time of night now. Some time in the darko clock. Let's just prop those together. Will they stay? Come on. Just stay there for a moment, please. Can't stand working with loose wires and things. I'd much rather be soldering very small parts on a circuit board under a microscope than trying to jumper wires around. It's not a fun thing. Come on. Okay. I think we have it in place, and just for added excitement, let's leave all of these joints uncovered, and maybe we'll get to let the smoke out again. Alright, so we've got power to there. What have I got? I'm going to dial up 5 volts on the lab supply. I'm going to leave it. What will I do? I'll set the current limit to 300 milliamps initially, and then I will bring it up slowly. So let's see what we've got. Ground on there, 5 volts on there. This is the danger right here. These joints are very close together. In fact, let's have at least some pretense at trying to keep the angry pixies in the right wire. There we go. So I'm just going to do it on this side. I'm going to turn it on. Turn on the output to the lab supply and we'll see if any smoke comes out. And it has hit the current limit, which is interesting. Okay, I'm going to set up to 800 milliamps. And that's good. It has not hit the current limit. It's running at 675 milliamps at 5 volts, which means that we do not have a dead short and there's no smoke coming out. So what I'm going to do now is turn the current limit up to 2 amps and turn this over. Well, that's interesting. Interesting. So we've got just that coming up. I'm going to prop that there and switch back to WLED and try to connect and just see if the D1 Mini is even running. It may not be. It looks like it's not. So there is, right, what did I get wrong there? Maybe I don't even have power to the D1 Mini. Let's find out. Multimeter. Cable's falling all over the place now. Alright, let's just see what voltage I've got. I need an on-screen multimeter as well. I've got 5 volts going to the D1 Mini. I've got, just confirming this, yep, 5 volts going in there. Let's check down this end of the chain. So we've got ground on this side, power on this side, 5 volts going to there. But the D1 Mini does not appear to be running. or at least it hasn't come up on the network, which is strange because it definitely has 5 volts on it. So hang on, I'm going to check its own onboard regulator. So see if the 3.3 volt rail is going. Yeah, okay. The D1 Mini has got 3.3 volts on it. So why is it not on my Wi-Fi? I wonder if it's done something silly like done itself a factory reset. Like of the come on, I'm just looking on my phone. I'm going to try switching. I'll see if that access point has come up. Maybe the access point isn't visible. That's why I couldn't see it on my phone earlier. Maybe it doesn't advertise. So I'm just trying to connect to the default WLED library. No. SSID. And it does not appear to exist. So, alright, I'm going to check in my network config. Where is it? Unify network control, and see if I've got, yeah, see if that device is up. It's been up for 2 minutes 48 seconds. That looks correct. WLED, it's on the correct IP address. And yet the web interface is not responding. What to do now? Alright. I'm going to let that sit for a minute and try and catch up on the chat. Matt said it's 0142 in the UK. And Electron Ash, 1:41 AM in Mordor. Okay. I am... It's nearly 3 hours. I'm going to have to... Ooh. Sorry. I'm losing the plot now. I really do need to take a break. So I just saw someone say, Electron Ash, does anyone else here cringe when you hear other YouTubers pronounce it multimeter? But I'm not sure which way around it is. I say multimeter. I know some people say multimeter. Is that the one that makes you cringe? I don't know. I've always said it as multimeter because it is 2 words. It's a multi-purpose meter. That's where the name comes from. It is a meter that does multiple things, so it's a multimeter. But yeah, I do hear people call it a multimeter, like altimeter. It sounds strange. Yeah, Matt Smith said multimeter. That's how I pronounce it too. Dodgy says, well-known fact that no one here in Australia knows how to speak English. We don't speak English, we speak Strine. Okay. Johnny said you had the current limiter on at boot. Yeah, so I thought maybe... Ooh, at boot. That is an interesting point because the D1 Mini would have powered up and it takes a big gulp of power. Oh, thank you. It takes a big gulp of power in order to initialize its radios. Yes. Maybe this is it. I just turned it off and back on again. Yep. And guess what? Hang on, I'm going to switch cameras. That was a great suggestion. Yeah, I did not think about that at all. All right, I'm going to switch to the overhead camera. I am going to wrap it up pretty soon, even though we don't have a solution. But we've got some interesting information. Look at this. I'm holding it backwards, upside down at the moment, so it's like right to left instead of left to right. But you can see that the last segments are flickering exactly the way they were before. Now, just to explain what was going on a second ago, and I think it was Matt who suggested the solution to that problem. The reason the D1 Mini did not come up on the network and it was not working and nothing was running is that when an ESP8266 or 32 starts, it has to initialize its radio. Like when it comes up on Wi-Fi, it initializes the radio and it pulls a big burst of current very briefly. I think it's like 600 milliamps or something like that. Most of the time it takes less power than that, but when it's initializing the radio it takes a fair bit, and it does like an auto-tuning process. Because I had the current limit set low on the lab power supply at the time that the D1 Mini started, the processor booted and it would have then tried to do its Wi-Fi initialization and failed, and then even if the D1 Mini is running, it will still never connect to the Wi-Fi network. So what I had to do was turn the power off and back on again with a higher current limit set, and then it initialized, came up on the network, started running, and now I can see it in the user interface. So that was a really good catch, Matt. Thanks for suggesting that. I think it was Matt. Or was it Johnny? Might have been Johnny. Yes, it was Johnny Bergdahl. Thank you very much. Yes. So, in fact, I'm going to come back into here, change brightness, and not that you can see anything. Oh, look, you can just see over here. Well, where is it? There. Here. You see that blue color that you can see coming just through? That is because I just changed it in the user interface. And if I change it to orange, you'll see it comes orange and green. So the thing is responding at the moment, but we still do have the flickering problem. Now, oh, Frank said, can you please share your wire jig file? I definitely will. So it's not actually mine. Now let's, I'm going to pull this up on Thingiverse. It's one of the items that I've got in my Thingiverse collection. So come on, Thingiverse, load, you can do it. Oh, there's a Bernie with mittens on Thingiverse. That's so cool. Come on. Come on, OBS, switch views. Switch. I want desktop. There we go. Here's Bernie with mittens. We can print him out. So, no, I don't want to sign up. I want to sign in, because somewhere in my thing, yes, remember me, somewhere in my list of collected items will be the soldering jig. So my collections, maybe it's in there. Come on, collections, likes. Oh, it must be in likes. What's the difference between collections and likes? I don't know. No, maybe I didn't have it in there in the collection. That's odd. So let's say soldering. I think it was called soldering fingers. I should be able to find it. There it is, soldering fingers. And there have been a few remixes as well. You know, I just clicked on this. So what I'll do is I'll drop the link to this one in the chat. I'm pretty sure this is the one that soldering. Those Americans that like to solder and then check with their multimeters. This is the one that I printed. And there have been a couple of remixes since then. And this one is interesting because this has some holes in the side of it. So it's got the normal fingers, but it's got holes in the side, which mean that you can do things like insert an LED into it and then hold the wires in place to solder onto the LED. So that's a pretty cool idea. See a different view. Yeah, so it's basically the same thing, it's just got those holes added, which could be handy in some situations. But that's not the one I printed. I printed the original one. And oh, here's another one. Need. Oh, this is funny. This other one that I'm just opening now. Because everybody forgets to put the heat shrink on before they do, before they solder the wires together. So this is the version with the holes in it, but it's got the text added, need heat shrink, as a reminder. So when you're sitting there staring at your joint as you're soldering it, it'll remind you to put the heat shrink on first. So that one, hang on, I'm going to drop this one into the chat as well. But now that you know what you're looking for, you can easily find these. Oh, Electron Ash said, my brother and I had an argument recently about how I say almond. Do you say almond or almond? I always say it so the L is silent, just almond. Like, as if it was like A-H-M-O-N-D, almond. But I know many people say almond. Okay, almond, yeah. Almond, yeah. Yeah, I say it the same way that Matt does. What am I doing? I'm talking about the pronunciation of almond. I am so far off the reservation that it is time to call an end to this. And Andy sent me a message saying the bribe was only for 40 minutes. It's now been an hour and 40 minutes. Yeah, I'm going to stop. All right. So, we never even got into Arduino lint at all. But it's been fun anyway. So, I'm tempted to leave this sign and not do any more debugging on it until I'm back on a live stream. Unless that'd be too boring. Maybe I should just do some poking around on it and see if I can figure out the problem and then just tell you at the end what it is, because debugging can end up taking a lot of time. At least I didn't break the internet. Yeah, that's right, Adam. So... don't I? I don't know. I'll think about that. Maybe I'll have a look at debugging or diagnosing the problem off camera and then tell you the result. Otherwise, maybe if I haven't got to it in the next week, I might bring it back out on the next live stream and keep debugging it. Don't know. Mitchell said next week live stream. Yeah. All right. It could just be a whole lot of you watching me soldering and trying things, though, which is not necessarily very interesting. Yep. Okay. I will go now and I will tell my stomach that I have something on the way for it. Alright. So, thanks everybody. And Matt, it's like 2 o'clock in the morning now, so go to bed. Someone else was saying it was 2 o'clock as well. I'm going to call it and say goodbye for another week. Thanks for hanging out with me. You've actually made me feel a whole lot better than I was at the start of the live stream. So thank you very much. And I'm going to try a scene switch and see if it ends. Bye.